So I guess we can open up the panel session. And just to go through the papers that we had in this session. So we had the end-to-end full-page optical music recognition of monophonic scores with documents via music score unfolding, sorry, the graph approach, and finally we had the notation assembly. Is there any question that we left out during the presentations? Jury, yeah.
I don't really have a question, but more of a note regarding the first paper. We were discussing the transformation from the two-dimensional image to the one-dimensional sequence, and I'm quite surprised that it works to just concatenate the features, because then I suppose the recurrent network has to do a lot of work if there are multiple lines of features for one stuff. But it's interesting that it works like that. It's a major observation for me. Like, I have to say that it's a good work that you've shown that this can be done, because last year when I was at IGDAR, I met someone who was doing full page text recognition via a similar technique, and they've used a transformer model instead of recurrent networks, and they used some kind of 2D positional encoding. I think you know what I'm talking about, since you're nodding. Okay, so I was curious whether you are like going to try this, or have you tried this, or what? Could you comment on this somehow?
Well, to be honest, that approach, which was full page handwritten text recognition with a transformer-based model in an image to sequence set, although it had very good results, the only thing that brought me back a little bit for trying it out is because it needed quite a lot of data. Indeed, in the presentation from IGDAR, author was very keen on explaining us that the key of the model to work was that it had a very heavy synthetic data streaming to work with handwritten text. And I think is one of the main drawbacks of trying image to sequence with the transformer model in particular. Of course, in music, it is viable. It is something that could be viable. But for historic documents, such as, for example, the ones that I have presented in Lauro Seco and Capitan, we still do not have good technology for synthesizing that kind of engravings, which would be also the most benefited one in a monophonic scenario. So although it is a very interesting approach to perform full page OMR, which also includes another things that the method presented here doesn't take into account, such as polyphony, homophony, and the rest of the things that you can find in music scores. We still need to rely on a good data generation pipeline and a lot of fine tuning. So we are thinking about it, but we are not applying it yet because we also want to keep it simple in the way that you don't need a lot of synthetic data and heavy data generation stream to be able to transcribe music scores.
Yes, that's nice, because that's what I was expecting you to answer. That because it fits with the paper we were presenting last year on this workshop about translation from diagnostic to the current scores. That you said that transformers require way more training data to work. So yes, it would make sense that yeah, okay. Thank you.
Another question on the same paper. What is different from cropping staves contextually? So first cropping the staves, having maybe a neural network or an algorithm that would crop staves and then input those staves in a sequence.
You mean the main difference in which terms?
I mean, would that, or is it the same thing that you're talking about, not accumulating error from two different blocks? Why can't we do that thing like first crop the staves and then input that as a sequence?
Well, the main difference is because for training both systems, as I have mentioned in my presentation, training those systems requires two models, one specifically trained for cropping staves or making layout analysis, and then a specific stage for transcription, which is done for single staff transcription. So the data labeling cost is higher than with this approach, because in this approach you only need just the full page transcription, which can be done by just typing down or in a music editor, putting the transcription of the contents of the music scores, while in the other case, you need to label each box that contains music and then transcribe them individually. So the method that we propose, the big difference is that it doesn't require such fine-grained data. You can only use better transcriptions of the full page, although it is limited, as I have said before, with monophonic scores.
Thank you. We have Paul.
So kind of building up on this question, what I was wondering if you have, or you or anyone really, because I don't think I've read many papers about music layout analysis in general, but the thing is that I was wondering whether you could compare like make a comparison of typical classical computer vision staff segmentation models with deep learning models, because my question is whether even with with classical vision, whether the output is so bad that music scores cannot use it at all, or are we really reaching good results with models, or how is the state on this sense?
Well, currently the reference value that we use in this case is an smear paper, which tried out or evaluated the use of layout analysis through deep learning based models. Well, it uses specifically a selectional autoencoder to detect all the music staves and then uses transcription. The thing is that if the layout analysis model works well, which typically does, transcription tends to be good. That's why we cannot get better results or barely better results than in the other case. The thing is that we do not put this method just for bad performance of the other one, but just for relieving the cost of training models and making algorithms work in this case. It's just an alternative approach. It is not competing to be the state of the art. Okay,
because what I was wondering is that I think during the old times of OMR prior to computer vision, they had well-established techniques of computer vision that deal with that. So I was wondering whether they really performed better or worse, or if they were very unreliable or not. That's it. But thank you very much.
Well, can I add something to this? It's a follow-up thing. Is that actually Antonio showed here that the layout analysis plus transcription approach works better than the one he was presenting. So I mean, it's a fair comparison in the sense that we are not saying that we are outperforming the state of the art. Actually, we are worse than the state of the art. But we think that this full page transcription approach is interesting as well. Not only, okay, the performance is not improving yet, the state of the art, but for example, it needs only one corpus for training, which is the images and the ground truth. You don't need to annotate the states. And also because in some future work that we are discussing how to do, for example, in text, it's very clear that you have lines and then you transcribe lines. But in music, now we have been dealing with monophonic staves so far, but we are not sure how to approach, for example, pianoform systems. Should we split the system into different states? Can we approach a full system end-to-end transcription process. So these are the things that we are researching, and we are not still, we don't know yet if they are better or worse, but we think it's worth researching in that direction. That's the point here, mainly, not just the performance.
Thank you, Jorge. Alexander?
I have a question to another paper. So I don't know, Paul, if you have a question for this discussion, then maybe you want to go first, or Adrian.
Actually, it was related to what Jorge just said on the paper. So,
And please go ahead.
So in this regard, I kind of had my follow-up to your reasoning was that if we try to go into more complicated models that do bigger tasks, we might end up losing performance, whereas the performance that we lose by cropping into much smaller slices of music, so to speak, and then adding more cost to the reconstruction of the score might compensate for it. So my rationale and kind of my thought process was, maybe we should, instead of trying to predict entire pages of music, try to segment into finer grained pieces of music that we can more reliably detect, and for which we are going to have more data. And in terms of what exactly we plan to do on piano form and this kind of more complicated stuff, I do agree that it's a complex matter. I've I've thought a lot about it in the last 6 months in my latest work, and there's definitely not a clean solution. And especially if you check the current formats, Music XML, to the best of my knowledge, deals with it by backing up and creating many voicings of the same thing, which doesn't really deter it from being, it's basically a sequence approach. And I think MEI does something similar. Maybe I'm wrong, because I'm not so
Yes, it's kind of.
But it's definitely an ongoing debate, but I think it all brings down to the very old discussion of the targets, the notation of music, and what are we trying to do and how. And I think this is a worthy discussion to open at some point during the workshop today.
Yes, we have to talk about that, Paul.
Yes, it's been. But anyway, I leave my point here, and I leave the stage
sure.
for
No,
further
I mean, this is perfect. This is what this session is for. I mean, this part of the session. Thank you for joining, Paul.
You're welcome.
Alex, do you want to go to the next paper?
Okay, sure. So my question is primarily to Carlos. So you showed in your work that you're trying to construct a graph for those small kind of, you can call them excerpts or snippets. How did you select those snippets? And primarily asking, like, for the next step, if you're able to construct a graph for these small snippets, how would it scale to a full image? Like, this is ultimately what we want to do, is like, how do you select those parts for which you construct graphs? Would you think it's feasible to do just a full image as well? Or would you then think it's getting computationally out of hand if you try to construct the full graph or full image at once?
Okay, thank you for the question. As I have said, this is currently a future work. We haven't tested on full pages. We have tested only in these patches that concretely, as you may know, in Muschema there are two types of relationships. One are that of let's say in graph relationship, like for example node head to beam, etc., and the other one are that of I think that the name is order relationship or time relationship, in order to follow up the music scores. So in order to get those patches, we only have we cut this sequence relationship, and we get, for example, the top left symbol that was in this subgraph, and then we are getting like a bounding box, for example, for the graph from the left top left symbol and the right on the bottom right symbol, and we are cropping this like in these subgraphs.
Mm-hmm. So you're primarily constructing a graph for the, I think it's called like syntactical relationship. The other thing,
Yes,
the
yes,
temporal relationship,
yes,
like which
that's
node
it.
comes
Yes.
first, yeah, or proceeding, something like this. I don't know exactly how it's called. Yeah.
Yes.
Okay.
I didn't remember the name as well.
Yeah. The precedence graph, I think something like this. Yeah.
Yes.
Okay.
Yeah, precedence is the formal name that we use.
That is.
I think we can move on to the next question, Adrian.
Yeah, sorry, it's back to Antonio for me. I'm just curious how your system would handle staves that are very vertically close to one another. Is that, if that's the case, often you have some notes, for instance, on ledger lines that are actually physically closer to another stave. And if you're splitting it up and putting it into that one long thing, do you think the network will just learn to ignore certain glyphs that are actually on another stave, or some other yeah, I'm curious to get your thoughts on that.
That's a really good question, because it is something that we haven't tried out yet. We believe, because this work is inspired by another one which has been performed in text transcription, and I believe that that overlapping between, that possible overlapping between music staves would be correctly handled by it, but I don't have any proof that it would do. And it is something that we want to try in the future to know how this system will behave in more complex scenarios where music staves are not very well aligned, or they can be overlapped, or there can be some symbols that can be close enough to another stave to be interpreted as being on the stave from the top. Yeah, that's something that it is still work to do.
Okay, thank you.
Any other points you would like to discuss?
Maybe to combine all of the speakers, one question, like, what is your prediction? Like, we've seen one approach where we have more like end-to-end thing, like we take the entire image, we fold it through a certain set of operations, and then get the direct transcription, versus something that is like more broken down to say, okay, we reconstruct a graph, we try to work out the relationships in the graph and try to predict this, and more like fine granular steps, and train specialized models on these. Which ones, like, what is your impression, which one we will see in the future as the most successful models?
Yeah,
Well,
full page image to graph. That's what you're asking for.
I mean, do you think this is something that would be feasible?
I don't know.
I guess
I
it would.
mean,
Sorry.
Anyway, well, the thing is that even if it is possible to do that, which I think, well I don't know, because graphs are difficult to handle. I mean, everything is complex with graphs. I mean, any algorithm is complex. Anything you want to do in a graph is complex. But the good thing about what Antonio was presenting is that you directly have something that is already the music that you are trying to encode, or decode from the image. Well, the thing is that even if you are able to get directly a graph from an image, you still need to parse or process the graph to do the encoding into standard formats. So I don't know, there's a lot of work to do there. Not only because of the complexity of the graph, but also parsing the graphs. And yeah, we are still struggling with the images, but what happens once you have your image encoded or decoded, depending on your perspective, into a graph, even if you have the perfect graph, you still have a lot of work to do. So,
in your experience, Jorge, is there anything missing, something that we maybe as a community would be able to help each other? But I'm speaking on the graph side of things. What is missing more concretely?
well, many things. I mean, I think one problem there is also the formats that we are using. For example, when Jan developed the Muskema ++, I think at some point he did some graph to MIDI. Alex, do you remember that? I think there is something there.
Yeah.
But for example, Antonio is doing whatever to hand run kern, and some other people want image to music XML. So even if something is developing datasets for the last part of the process, from the graph or from the intermediate format to the final format, if one is doing it with MIDI, another one is doing it with XML. So, I mean, there's also, yeah, a lot of different objectives, different formats, different approaches. So the problem here, I think, is that depending on what you are going to do with the music that you retrieve from the image, then different formats are suitable. So I don't know. For example, I would like to do more research on the parsing of the graphs, but I cannot parse the Muskema ++ graphs as I want, because I want to parse them to retrieve, for example, hand-run kern, but there is no data for that. So yeah, it's not only a matter of data. Of course, we can always demand more data, but it's also like deciding a pipeline that everyone agrees, which I think that's already possible, and then try to focus the efforts on building data for the agreed pipeline. But I think that's not possible.
Yeah, the underlying assumption for the Muskema ++ dataset was, if I remember correctly, that the last step, if you have this music notation graph, that going from there to whatever output format you have is a deterministic step that in theory should be quite simple and straightforward. In theory, not. I'm just saying, I think this was the underlying assumption for the creation of the data. But maybe also to get Marie a little bit into the conversation here. So you think that while it's interesting to think about how to get the graph to the graph directly, for real life applications for the foreseeable future, we'll probably still see a lot of handcrafted rules and heuristics around.
If I may intervene on this topic, however,
yeah,
I think that precisely, and since you mentioned also Maria, precisely one of the points of standardizing what the output we want is precisely that then we can reutilize also this kind of midterm heuristics. We can reutilize the input, so to speak, the vocabulary of tokens that we use, and so on and so forth. And another point that I wanted to bring up is the fact that maybe we're handling the whole process in the opposite order, because maybe we're trying to build our own formats that suit our perspective of handling the problem, object recognition or sequence to sequence or whatever, instead of trying to say, okay, it's a music XML, it's an MEI, it's a whatever we want to work with, it's what we want to graph. So we want to try to have the tools and the representations that better allow us to produce these formats. And for instance, and bringing the conversation in particular to music XML, because it's the one that I'm most familiar with, but I think this is extensible to anything. Music XML, at the end of the day, it's a tree representation formulated as a sequence. So many of the relationships that you can build graph relationships in the same style, maybe not as fine-grained perhaps as the Muskema ++, using only a music XML file. You do not need anything else. So one of the possible solutions can be, okay, we want to predict this. We develop a system with which we can model a music XML file as a tree reliably. So we develop the rules to detect the primitives that we are most interested with, that subset of music XML or whatever format we want to, in order to build the format. We standardize the rules, we build the format automatically, something like that, for instance. And the good thing is that if we restrict ourselves, because the thing about graphs, as you said, is that they're very tricky to work with. We have problems about the computational cost of trying to analyze them. But if we restrict it to trees, for instance, we have many ways, many shortcuts, many different techniques that significantly reduce the cost of this. So for me personally, I think the way forward is tackling one of these big formats, let the representation complexity go to them, and then apply the common subset, the biggest common subset for all applications of music XML for music into this format. And then when we need some specific features, then we add them as extensions, as David Rizzo was kind of highlighting during his presentation. So I don't know, maybe it's too broad of a suggestion, but the thing I will say is I have worked on an implementation on this direction, and I've been able to do end-to-end music recognition that is parceled directly into a file. So it's a proof that it's possible. It's still immature, but it's definitely possible.
Well, but another solution is to promote conversion between standard formats. I mean, if you can go from music XML to MEI and go back, and that works, if that would work, then
that's the point, that you can.
You can, but it's not perfect.
I know, but the point, that's what I was also emphasizing with the biggest common subset. Like, we have to agree on what is the part of music that we cannot renounce to, so to speak. And let the people who handle the standards handle this complexity, because we are too few and too little to handle it by yourselves.
Yeah, yes. I mean, but it's something that they don't agree upon. So we can maybe wait until they do, or
May I speak?
Yes.
Yes. My point of view is that I have worked a lot with all these things, and everything that's not as large, no dynamics or no, nothing like that can be represented as a tree. What you cannot represent is anything that has to do with any link between elements. For example, a slur, a crescendo, something like that. But all the contents in music, even triplets, can be represented by trees.
I'm aware of that, and that's one of the solutions that I work with. Is I think it's the preferred way, I think, to handle it in most formats, which is the continuing tokens. Tokens that specify the start, beginning, and end, start and continuation and end of one of these ongoing tokens. And I was surprised because most models actually can handle with this, doing in an end-to-end fashion. I know it's not perfect, but it's just a suggestion, an idea, because I think that the representational power of trees can be a good middle ground between the interactability of graphs and the restrictions posed by sequences.
And can be split into different problems. Maybe the trees approach can recognize all the music without ornaments, and the other part, and in another problem you link then later things, no?
Exactly, but that's why I also wanted to emphasize that we need a target representation at the end of the day that we want to apply this all for. Because if we know the restrictions of this, and we know the biggest common subset of music, the tools that we are going to develop are going to be applicable to the 90% of the cases, and then we develop extensions for that extra 10%.
Mm-hmm. Sure.
May I comment on this? Because actually, I also think that trees are like the thing that we should strive for, because when I started doing optical music recognition, I first thought it's sequential, it's easy. Then I realized, oh no, it's complex, it's two-dimensional, and it's not that easy as I thought. And I started to think that graphs were the way to solve this. And now I'm a PhD student at a department that's full of linguists. They do natural language processing, which is something I haven't done before. And it's interesting to me to realize how graph, or at least tree-like, is a natural language, because the sentence of a structure is a tree-like because there are dependencies between individual words. So each sentence is actually a tree. So I was thinking about music, that we could use these concepts from natural music, natural language processing, and maybe we could encode the music in a sequence that in fact was some sort of a tree. Because for example, if you take a group of 8 notes joined together by a beam, you could think that it's sort of a word, kind of, and a measure is kind of like a larger word or a sentence. And if you think about slurs, these seem to break this tree-like structure, but actually natural language does that also with pronouns. You can refer to things that you have said before. So like at the end of a slur, you can say, here ends a slur that has begun like at the subject of the previous measure or something like that. So I think it's an interesting thought that occurred to me, and I would like to explore this future in my work. Like, what are the similarities between natural language and music representation? Maybe this could lead somewhere. I don't know. Just a thought.
I actually wholeheartedly agree, because the other thing about trees is that then you can use all the parsing techniques, all the tree decoration, abstract syntax tree technology that we have for programming languages, to basically you have a very basic tree output from an OMR, and then you can decorate it further by a use of a pre-existing technique. And another thing that also Yuri mentioned was the fact that we can now have fine-grained distinctions of what we consider like a word, like everything. So we can reduce the scope of recognition to improve the power. Because one of the issues now is that we cannot recognize reliably small symbols. We need a higher DPI, but by using higher DPI, then we cannot work with full pages because it's intractable. But if we have a notation that allows us to reduce and augment the scope of recognition, it also helps improve the results. Provided, of course, that we can then compose the final output, which is again easy because we can decorate the tree. We only need the recognition of the first tree, we combine them, and then we decorate them to propagate the music semantics. So yes.
I think thank you very much for all the questions and the discussion you raised.